Welcome to this predicted paper from On Maths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our On Maths site. On Maths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. So we need to first of all understand what a cube number is. So a cube number is the answer to when you get three integers or whole numbers and we multiply them by themselves three times. So 1 times 1 times 1 is 1, 2 times 2 times 2 is 8, 3 times 3 times 3 is 27, 4 times 4 times 4 is 64, and 5 times 5 times 5 is 125. So 1, 8, 27, 64, 125 are all cube numbers, and it goes on forever. And this question's asked us to find all the odd, or an odd, cube number that is smaller than 100. So it has to be odd, so that gets rid of the 8 and the 64. And it has to be smaller than 100, so that gets rid of the 125. So I can either write down 1 would be a fine answer, or 27. I'm going to go for 1. So with this question, we need to first of all count how many sides this polygon has. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 sides. And we just need to know that a 10-sided shape is a decagon. Now we are expected to know all of the names of shapes between 3 and 10 sides, so if you don't know them already, just sit down and learn them. Multiples are just a numbers times table, so to write the multiples of 11, we're just going to do 1 times 11, 2 times 11, 3 times 11, 4 times 11, and 5 times 11. Now we're not going to do any more because it says it just wants the first 5. So I'm just going to write those down in a list with commas, separating them. Whenever you have this situation where you've got two lines intersecting or hitting each other, the two angles that are created either side of the line are always going to be equal. And we call these vertically opposite angles. So A is going to equal 120 degrees. You'll normally also need to write down the fact that they are vertically opposite angles. So we're just going to start by writing the number a little bit bigger. So it says to 2 decimal places, so we're going to draw a line after the second decimal place. Now all the numbers to the right are going to disappear. They're going to turn to 0, and because it's a decimal, that just means we get rid of them. But we have to look at this number first. Now if this number is less than 5, we just keep the number to the left, so 8.17. But if it's 5 or more, then this 7 goes up to an 8. So this will be 8.18. This question's all about like terms. So what we can do is we can add this 10u with this 11u to make 21u. We can also add this 6v with this plus 4v to make 10v. We can also add this 10w to this minus 6w. So 10 take away 6 is 4w, so plus 4w. But we can't add a u term to a v term to a w term. So we have to just leave them be. So our answer is 21u plus 10v plus 4w. But we can multiply them, we just can't add or subtract them. So for shop A, they're selling the rulers in lots of 3. And so we just need to get our 60 and divide it by 3 to figure out how many lots of 3 we have. So we've got 20. So if one bundle of rulers costs £1.50, then 20 times £1.50 would be £30. So in total it would cost £30 at shop A. We're going to do the same for shop B. Their bundles are 5 rulers, so we're going to do 60 divided by 5, which is 12. So we're going to buy 12 bundles at £2 each, and that will be £24. So the cheapest price is at shop B at £24. So if we just add the amount of sides each of these shapes has, a triangle has 3 sides, quadrilateral 4, pentagon 5, hexagon 6. And notice what's happening with the number of edges. They're multiplied by 3. Each time they're multiplied by 3. So all we need to do is get the 15, multiply it by 3, which will be 45. So there will be 45 edges. The range is the biggest number, take away the smallest number. The biggest number in this STEM diagram is found at the bottom right. So this 9 here represents 69. So it would be 69, take away, and the smallest number is always at the top left. So this 4 here represents 34. So it'd be 69 take away 34, which is 35. The midpoint of a line is the halfway point, and we can see that it is roughly here. And there's a couple of different ways we can work this out. Either we can just look at the graph and just kind of try and work it out that way, or we can use the equation. Now the equation is, to find the midpoint for the x, what we do is we add the two x coordinates together and we divide by 2. And so the x coordinate of A is 3, and at B it's 0. It's going to be 3 plus 0 divided by 2, which is 1.5, 1.5. So we know that's going to be 1.5. I'm going to do the y a slightly different way, maybe. We've gone from -3 to 2, and so we can just look at the fact that the halfway point here is going to be at -0.5. That's going to be -0.5. If you didn't really see that, we can use the equation. The equation's simple because it's just y1 plus y2 divided by 2. And so the y coordinates are 2 and -3. 2 plus -3 is just going to be -1. -1 over 2 is just going to be -0.5. Instead of doing 0.43 times 16, what I'm going to do is I'm going to do 43 times 16. So I'm just going to get rid of the decimal and just change it to 43. But I've got to remember what I've done. So how have I managed to do that? Well, I've times it by 100, and that will be important at the end. And to do 43 times 16, there are loads and loads of different methods. Just pick whichever method you enjoy doing or that you find easiest. I'm going to do the grid method, but it by no means is the best method. It's just the one I'm choosing to do. So 43 is 43, and 16 is 10 and 6. So 40 times 10 is 400. 40 times 6 is 240, 10 times 3 is 30, and 3 times 6 is 18. Then I'm just going to add them all together. So 400 plus 240 plus 30 plus 18. And when you add those all together, you get 688. Okay. Now, the problem is that obviously this is not going to equal 688. What we've done though is we've times it by 100. So to find the answer, all we need to do is divide this, undo that times by 100, so divide it by 100. When we divide that by 100, we get 6.88. To get from the length of a square to the area, we square the length. To work backwards, what we do is we square root, because the inverse of square is square root. So we've got 196, and we're going to square root it to find the length. So we work out the square root of 196, which is what number times itself is 196. And you should learn them from 1 to 15, so you should know all of the square numbers from 1 to 15. So you should know that the answer is 14. So the length therefore is 14. So to work out what the perimeter is going to be the distance around the square. So if I draw a square out, we know that each of these lengths are 14. So it's just going to be 14 times 4, which will be 56. So with this question, I'm just going to write it out a bit bigger so we can see what we're doing. And one of my rules is if you've ever got a fraction or a set of brackets in a question you're trying to solve, always get rid of those first. So what I'm going to do is I'm going to do myself a little grid to be able to solve these brackets. So we've got a 3 there, 6x and minus 11, and we're timesing them. And we're just going to multiply out the brackets. And if you've got a different technique to do this, that's absolutely fine, use that. 3 times 6x is 18x. 3 times minus 11 is minus 33. So we're just going to rewrite this as 18x minus 33. Now we are solving, so we're going to put our solving lines in. And the first thing I want to deal with is this take away 33. So we're going to do the opposite of that, the inverse, which is plus 33. And whatever you do to the left hand side, you have to do to the right hand side. So we're going to add 33 to both sides. We're left with the 18x on the left hand side because we've got rid of the minus 33. And on the right hand side, we've got 180. Next, we want to get rid of this times 18. So we're going to do that by dividing both sides by 18. On the left hand side, we're left with our x. On the right hand side, we're doing 180 divided by 18, which is 10. So our answer is x equals 10. So we're asked to reflect this shape along the line y equals x, and y equals x is a diagonal line where all the x values are equal to the y values. So at the bottom here we've got x is 10 and y is 10, so that coordinate would be 10, 10. And then obviously this coordinate 4, 4, etc. So we need to reflect it across this line. And so if I pick a point, I'm going to pick the top one. We can see it goes 4 diagonals to hit that line. So 1, 2, 3, 4. So it will go another 4 diagonals. So that will be one of the coordinates there. And I'm going to do the same with the bottom one. So 1, 2, 3, 4, 5, 6 diagonals. 1, 2, 3, 4, 5, 6 diagonals. So it will be there. And then finally, I'm going to do this slightly harder one. So we've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Kind of goes over the other one. Ends up here. So if we join these up, and we need to label it B. So with a stem and leaf diagram, the numbers in the middle often represent tens. They could be units. So we look at the key first of all, and we see that 3 line 9 means 93. So the numbers in the middle are going to represent 10. So this is a 90. Now we're looking for English, so this will be 92. So our first number will be 92. Then this will be 10 tens and a 4. So it would be 104. 11 tens and 1, so 111, and then 11 tens and 2. So to find the median, we go cross out the biggest and smallest until we're left with 1 or 2 in the middle. Here we're left with 2. So what we're going to do is we're just going to add the 104 to the 111, and we're just going to divide that by 2. So when we do that, we get 107.5 or 0.5. So our answer is 107.5. Another way of writing a to the power of 6 is a times a times a times a times a times a. And another way of writing a to the power of 9, power of 5 is a times a times a times a times a. Now you might notice that altogether there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 A's that are being multiplied together. When you multiply something together 11 times, you get that thing, which is an A, to the power of 11. An easier way of doing this is just adding the powers. So when you've got the same base, which we do here because they're both A, you just add the powers together. To find the surface area of the cuboid, I'm just going to label the faces and do them individually. So we've got A, which is 24 by 13. So we're going to do 24 times 13, which is 312. Next we're going to do B, which is this one at the top, and it's 24 across and 8 is the length. So 24 times 8, which is 192. And finally C on this side here, which is going to be 13 times 8, which is 104. Now notice that the faces all have the exact same face on the opposite side. So this one at the back is also A, this one at the side is also C, and the one at the bottom is also B. So what I'm going to do is add up all the areas of the squares and double it. So to work out the surface area, we're going to do 2 times and then 312 plus 192 plus 104, and that will give me 1,216 centimeters cubed squared because it's an area. So for this question, we just need to pick one of the coordinates, and I'm just going to pick this one here. And we just need to work out what the coordinates are. Well, it's going up in 2, so it's going to be 4 on this side, and this is kind of 4.5, so that's going to be 19 there. So we know it's 19 at the bottom and 4 at the side here. So we're going to have a look on our table for a 4 and a 19. We've got a 19 and 23 here. It's got to be a 4 and a 19, which is here. And it shows that the 4 is for paper 1 and the 19 is for paper 2. So our answer will just be paper 2. So whenever we have a scatter graph, chances are we'll be drawing a line of best fit. And so that's what we'll start off with, draw a line of best fit in. And it says we're looking for a height of the box, or an estimate of the height of the box with the width of 17. So 17 is here. So the width of 17 will be a line across, let's try and get this just right, line across there. And what we do is we draw a line down when it hits the line of best fit. Now looking at the scale here, this seems to be going up in 2s. And so this line here would be at 3. Bearings are always from north and go clockwise. So let's have a look at where the north line is. Well, the north line is here. And to find the bearing of B from A, so that means we're at A and we're looking at the angle of B, we're going to go clockwise. And you can see on the diagram it's already labelled as 42 degrees. But the third rule of bearings is they must be 3 digits. So instead of 42, it's going to be 0, 4, 2. Here we're given angles on a parallel line, and the first thing I do is just find out what letter they connect with. And if you look, this is kind of like an upside down F, so they're F angles, and F angles are always equal, so X is going to be 11 degrees, that's the easy bit. Difficult bit is figuring out Y, and the way I remember it is that cor F bonding, and I just put the F in there, so it's going to be cor F bonding is what's in my head, but what I write down is obviously cor S bonding angles. But it's just a way that I have to remember it. One thing we need to know about a parallelogram is that the lengths that are opposite are equal. So this length here is going to be 5 centimeters, and the length at the bottom is going to be 10 centimeters. And to work out the perimeter, all we need to do is add up the length. So what I do is I pick a point and I go around the shape. So we're going to go around the shape. So we're going to do 10 plus 5 plus 10 plus 5, and then when I return to the point where I started, I then stop. And when you do that, you get the answer of 30. And it's a perimeter, it's a distance, so it's centimetres. Some people often forget and put centimetres squared. You only do that when you've got an area. So with a perimeter, it's a length, it's a distance, so it's just 30 centimetres. The front elevation of a shape is the view you'll get if you were standing at the front. So if you imagine you're standing here, the only side you will see is this side here. And what will it look like? Well, it will look like a complete square or rectangle. And how high will it be? Well, it will be 6 centimetres high. And how wide will it be? Well, it will be 2 centimetres wide. So what we're going to do is we're going to just draw a rectangle that is 2 centimetres wide and 1, 2, 3, 4, 5, 6 centimetres tall. There we go. And make sure that you don't add any three-dimensional aspects to it, that you don't do something like this, have some 3D stuff on it. No. Whenever you do a front elevation, it's exactly perfectly two-dimensional. To work out the area of a rectangle, we just multiply the width and the length. Here they are mixed numbers, so all we do is the width times the length. Now when you multiply with fractions, always make them top heavy first, or improper, and to do that you times the big number by the bottom and add it to the top. So we're going to do 1 times 2 and add it to the top, so 3 over 2. Same with this one, 1 times the 3 at the bottom, added to the top. 1 times 3 is 3, add to the top is 5. Now we've got to get the numerator, we don't need to get the numerator the same, we're multiplying. All we do now, really easily, is just multiply the tops and multiply the bottoms. So we've got to convert 15 over 6 into a mixed number because it asks for a mixed number. So 15, how many 6's go into 15? Well, we're first of all going to have 2 whole ones. And how many left over? There are going to be 3 left over. Now, 3 over 6 is the same as 1/2 because we can divide top and bottom by 3. So our answer is 2.5. So to find the area of a rectangle, we do length times the width. So here, to find the area, we will do the 10 times the whole of the 10t plus 4. And to show that we're doing the whole of it, we put it in brackets. So a different way of writing that is 10 brackets 10t plus 4. And whichever method you use to expand brackets, feel free to do it here. I'm going to just do the grid method, but whatever method you prefer. Actually, I don't need the, I've done too many here. Let's get rid of that. So we've got 10 times 10t plus 4. So and we're timesing them, so 10 times 10t, 10 times 10 is 100, so it'd be 100t, 10 times 4 is 40. So our answer will be 100t plus 40. So we're asked to find angle BCE, and that is going to be this one here, because you start at B, go to C, and then go to E, and it's the angle you make. And I might just choose a different colour, because we've already got red on here. So we're looking for this angle here. Now, my advice for these kind of questions is always just try and work your way around the shape with angles you know. So, for instance, I'm going to start with this angle here, and we're going to call this angle ADC. And we know that that must be 79 degrees, and always write down the reason, and we know it is because that is an isosceles triangle. So if you look, we've got an isosceles here, this one, and this one. And the bottom two angles, and I use the word bottom because I always imagine an isosceles as being this way up. The bottom two angles in an isosceles are always equal, so that must be 79. Now we've got 2 of the 3 angles in the triangle, and the last one is going to be angle DCA. And to work out what this angle is, we're going to take it away from 180. So we're going to do 180, take away the 279s we've just worked out. And the reason for that is angles in a triangle equal 180 degrees. Okay, so when we do that, we do 180, take away the 158, and we're left with 22 degrees. So we know that this is going to be 22 degrees. And now we can actually work out angle BCE, because it's going to equal angle DCA. And the reason for that is they are vertically opposite angles. So that's just going to equal 22 degrees. Now, it is really common for these types of questions for you to get maybe 1 or even 2 marks for the answer, but 1 or 2 marks normally for the reasons and for the explanations. In fact, I've seen quite a few exam questions where you get 2 marks for the reasons and only 1 mark for the answer. The important thing to realise in this question is that we know a female has been selected, so we can just basically get rid of all of this part of the frequency tree because it's not relevant, because we know a female has been selected. So there's 29 females altogether, and we're looking for the probability that the female chosen at random picked action. So it's just simply 16 over 29. This looks like it's a really tricky question, and it is a little bit tricky, but it's a little bit easier than maybe it looks. The highest common factor is found when you have the prime factors, which we do, of 2 numbers, and you put them into a Venn diagram. Then you can find the prime factor, the highest common factor, by multiplying all the numbers in the overlap. So we're going to rewrite these numbers. Just instead of squared, we're just going to write them out without index form. Just makes it a bit easier. And so I'm just removing the squares, and we're going to draw ourselves a Venn diagram. So let's just do a rectangle at the outside. I'm going to try and do some nice circles here. Try my best anyway. Okay, so on the left hand side we have the 450, on the right hand side we have the 132. So we'll start with the 450 and the numbers. So actually looking at the numbers, looking at the factors at the top, the prime factors, we can see they both have a 2 in them. So I cross them both out and put 2 in the middle. We can see they both have a 3 in them. So cross those 3's out and put 3 in the middle. And then 450 has a 3, a 5 and a 5. And 132 has the 2 and the 11. So to find the highest common factor, as I said, you multiply all the numbers that are in the middle. And so the highest common factor will be 6. To rearrange this, I'm just going to write out the equation again. And I'm going to put my lines in. Okay, so the first thing I'm going to do is try and make the x positive, because we're looking to make x the subject of the formula, which means we need it to be x equals. So what I'm going to do is just add x both sides. So we've got x plus m equals 10. Then we want to get rid of anything on the left hand side that's not this x. So we want to get rid of this plus m. So we're going to do that by subtracting m both sides. So we've got x equals 10 minus m. So our answer is 10 minus m. X equals 10 minus m. We can rewrite this question as 2 over 1 divided by 1 over 15. Basically, when you've got an integer, which we do here, a whole number with 2, you can just write it as a fraction of that whole number over 1. Next we do keep, flip, change. We keep that first fraction, 2 over 1, change that divide sign to a times, and flip the second fraction. Multiply the tops, multiply the bottoms, and 30 over 1 is just the same as 30. So our answer is 30. So to find the area of a rectangle, we just multiply the width and the length. So that's what we're going to do here. But whenever you have an expression representing a length or a width or anything really, you just put brackets around it. So we go u minus 2 times u plus 9. Okay, and the way we do this is with our grid. And just going to draw out the grid. And so we've got u minus 2, and we're multiplying it by u plus 9. Don't want too many for some reason. And so we've got u times u, which is u squared, u times minus 2, which is minus 2u, 9 times u, which is 9u, and 9 times minus 2, which is minus 18. And what we're going to do is we're just normally going to be able to add these ones together. So our answer will be u squared, and then we're going to do 9u plus minus 2u. Well, that's just going to be 9u take away 2u, which is 7u. So plus 7u, and then minus 18 at the end. I'm going to start by expanding these brackets. You could have divided both sides by 2 and then expanded the brackets on the left, but I'm just going to expand them all because it might be maybe easier, I don't know. So we've got 2x minus 44. Get our lines in because we're solving. And the rule is that we get rid of the smaller amount of x. So we've got 2x here and 12x on the other side. So we're going to subtract the 2x from both sides. And so that'll give us 10x minus 84 is less than minus 44. So we've got minus 44 there, but that won't be a problem because we're going to add 84 to both sides. And so we've got 10x is less than 40. And then we're going to divide 10 both sides to get what x is, or what x is less than. And that would be 4. So our answer is x is less than 4. So we're asked to find the value of n where both sequences have the same term. So I'm going to start off by equaling both nth terms to each other. And then we can find the value of n which gives the same term. So I draw my lines down. And I'm going to start off by getting rid of the n's from both sides. So we look to see which is the smaller amount. So we've got 12n and we've got 6n. So the smaller amount is the 6n. So we're going to take away 6n both sides. And so that would be 6n plus 19. And we've got rid of the 6n, so it's just 79. Next thing we're going to do is get rid of the 19. So take away 19 both sides. And so we've got 6n equals 79 take away 19, which is 60. And finally, we just go divide the 6. And so that would be n equals 10. So the value of n is 10. Now we can just test this, because if you do 6 times 10, which is 60, 60 plus 79, which would be 139. And then if we do the same for the top one, 12 times 10, which is 120, plus 19, which is 139. So they both have the same term when n is 10. We know that when you multiply powers with the same base, and here we've got all these as base v, you add the powers. So we're actually looking at what do we add to 11, which is this one here, to get to the 15. 11 plus 4 is 15. So w therefore equals 4. Factorizing is the opposite of expanding. So instead of multiplying something out of a bracket, we're putting it in a bracket. I'm going to start just by putting the bracket down. And we're going to ask ourselves, what number can we divide out of 18 and 33? And we need the biggest number we can divide out of both of them. So we're essentially looking for its highest common factor. So 18 and 33, that would be 3. And there's no letter we can divide out of both of them because 33 doesn't have a letter. Next we ask ourselves, 3 times what is 18x? Well, 3 times 6 is 18. 3 times 6x will be 18x. Then we ask ourselves, what times 3 is 33? And that's obviously going to be 11. And you can expand that. 3 times 6x is 18x, 3 times 11 is 33. So we know we've got the right answer. So our answer is 3 brackets 6x plus 11. So our triangle says that speed equals distance over time, and average speed is the total distance over the total time. So when we're looking for average speed, we want to work out, so we're just going to write average speed or speed, and it's going to be the total distance. So the distance starts at 0, goes up to 30. So the total distance is 30, and the time starts at 10:15 and ends at 11. So that'll be 45 minutes, or, well, we should do it in hours, because the units we want in hours. So it would be 0.75. So 30 divided by 3/4 would be 40. So it's going to be 40 kilometers per hour. To find solutions for quadratics on a graph, all you need to do is find out where the graph meets the x-axis. Okay, so the coordinates this graph meets the x-axis are here and here, and that would be minus 0.8 and 0.2, and they're also called roots. The word truncated means that we just literally cut off the next number along. So if we imagine this is our number, we just cut it off. So it's not the same as rounding. We just don't change this digit at all. We just cut off the remaining digits. So the smallest number it could be before it was cut off is 79.500000. The largest number it could have been, well, it could have been 79.5999, etc. So that's the largest it could have been. So to do our error interval, well, the smallest it could have been is 79.5, and it could have been 79.5, and we'll call this x. But we're looking at any number that is less than 79.6. So any number that's less than 79.6. If it was 79.6, then when we cut it off, it would show as 79.6. So the way this formula works is we have m, which is the final amount. The 2000 here is our initial amount. The decimal in here is our multiplier, and the power here is the amount of years. So the way multipliers work is they are the percentage divided by 100. So if we go the other way and times it by 100 to make it back into a percentage, it will be 102.9%. Now it says, what is the interest rate of the bank? Well, the interest rate is always going to be 100%. Well, this 102.9% is 100% plus the interest rate, which will equal the 102.9%. So the interest rate is going to be the 2.9%. You always start off with 100%. So if I put £5 into my bank, I've got 100% of that £5, and then the interest rate is on top of that 100%. So our answer here will be 2.9%. In this question we have a right angle triangle, and we know two of the sides and we're looking for the third one. So that screams to me Pythagoras. So Pythagoras is a squared plus b squared equals c squared, with c squared being the hypotenuse. The hypotenuse is the one opposite the right angle, so this is going to be c. And we'll label the other ones a and b, it doesn't matter which way around they go. So a is 5, so it'd be 5 squared plus 12 squared equals c squared. 5 squared is 25, 12 squared is 144. And so 25 plus 144 is 169. Now that's c squared, so we need to solve here, and the way to solve is just to square root both sides. And so it would be 13 equals c. Because it's distance, we don't worry about the negative 13, so just the positive 13. So we know c is 13, so we need to know what the total length around the triangle is. So we're going to add the 5, the 12 and the 13 we've just found. When you do that you get 30. So we know there's 30 meters in total. Now it does say that we need 90 milliliters of paint per meter of wood. So the amount of paint needed is going to be the 30, because that's the total distance, times the 90, because we need 90 for every meter of paint. 3 times 9 is 27, and then put the 2 zeros at the end. So the answer is 2,700 milliliters. So there are two outcomes that it will rain once in the next 2 days, and that will be rain and not rain, and not rain and rain. So to work out the probability, it will rain on Monday and then not rain on Tuesday. What you're going to do is just multiply 6 over 20 by the 2 over 7. So 6 over 20 times 2 over 7. And that will give us 12 over 140. And to work out the probability, it will not rain on Monday and rain on the Tuesday. We're just going to multiply the 14 over 20 by the 5 over 7. And so that'd be 14 over 20 times 5 over 7. And that will give us, was it 70 over 140. Now we're looking for the probability it will rain and not rain, or not rain and rain. The word or in probability means add, so we're going to get that 12 over 140 and add it to the 70 over 140, and that will give us 82 over 140, and then we can cancel that down to 41 over 70. So here we're given a right angle triangle, and the question involves two lengths and angles, so we know we could be using trigonometry. So let's start by labelling our sides. The one opposite the right angle is the hypotenuse, the one opposite the marked angle is the opposite, and the one between the right angle and the marked angle is the adjacent. Now notice the hypotenuse doesn't have a number or letter next to it, so let's get rid of that. Next thing we do is draw our trigonometry triangles. So we've got SO, Ca, Toa. Now we've crossed out the H, so we're not going to be interested in the SO or the Ca. So it's going to be Toa. Toa is short for tan the angle equals opposite over adjacent. The angle is 60, so it's tan 60 equals x over 1. And so now here we're looking for the exact value of x. So if I times both sides here, let's just get our solving lines in here, and times both sides by 1, or just get rid of the fraction, we end up with x equals tan 60. Now you need to know off by heart what tan 60 is, and we can work it out just briefly by drawing a right angle triangle. Sorry, not a right angle triangle, an equilateral triangle. So that is going to be 60 by 60 by 60. And we're going to put all the lengths around the outside as 2. And what I'm going to do is I'm going to cut it down the middle. And I'm just going to cut it into half. And so the length at the bottom will be 1. And using Pythagoras, we've got to work out the length here. It's going to be 2 squared, which is 4, take away 1 squared, which is 1, will be 3, and then square root it would be root 3. So we know that's going to be root 3. So looking at labelling the sides here, just pick a colour to make sure it's nice. So we've got the hypotenuse here, we've got the adjacent here, and then the root 3 will be the opposite. And so we're looking for tan 60. So tan, as we know, is the opposite over adjacent. And so tan 60 is going to be the opposite, which is root 3, over the adjacent, which is 1 in our diagram there. So tan 60 is equivalent, it's the same as root 3 over 1, or just root 3. So we're asked to go from B to C and name the vector. So we can't go directly from B to C because we don't know the name of that road. So we've got to go from B to C just going down roads that we know. Well, we know the name of this road and then we know the name of this road. Now that first road is going to be A, but we're going the wrong way up it. So it's actually going to be minus A. And the second road we went down is just B, and we're going with B, so it's a positive B. Now you could write that as B minus A as well. So the first thing I ask myself is what has happened to this shape? Well, it's actually changed size, so we are looking at an enlargement. And the next thing I need is the scale factor. So the scale factor is, well, let's have a look at the squares at the bottom. So we've got 1, 2, 3, 4, and it's changed to 2. So 4 times what is 2? Well, that's going to be a half. So it's actually halved. And last thing I need is the center of enlargement. And those are coordinates. Now to find those coordinates, we join up our two triangles. Let's try and get a good, there we go. And we just join up like for like points. So I'm going to join up the two tops, and I'm going to join up the two right angle parts, and I'm going to join up the bottom right part as well. And you notice that they all cross at this coordinate here, and that's actually our center enlargement, so that's going to be 8 minus 7. You can complete a unique version of this paper by going to our OnMaths site. OnMaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing.